If you traveled to the edge of a black hole and stayed for just 1 hour, you would return to Earth to find that everyone you've ever loved has been dead for centuries. You haven't moved through a portal and haven't used a DeLorean. You've simply exploited a glitch in the fabric of reality. We've been told that time travel is a fantasy, a dream for the cinema, but the truth is far more haunting. Time travel isn't just possible, it's happening to you right now. You just don't have the engine to notice it. Yet, welcome to Deep Science Explained. For over a century, the mystery of the universe has been locked behind the ticking of the clock. We perceive time as a river, flowing at a constant speed in one direction. But physics tells a different story. In the realm of deep science, time is not a constant. It is a variable, as flexible as a rubber band, and as fragile as glass. Today, we are dismantling the Hollywood myth of the time machine and replacing it with something much more terrifying, the block universe. We will explore how gravity can stretch a second into a lifetime, why the grandfather paradox might be a logical impossibility, and how quantum mechanics suggests that the past, present, and future are all happening simultaneously. Put away your flux capacitors. We're going into the real physics of the fourth dimension. To understand time travel, you first have to realize that time is not universal. Einstein's theory of general relativity changed everything. He discovered that space and time aren't separate. They are woven together into a single fabric called space-time. Imagine space-time as a vast, invisible trampoline. If you place a bowling ball in the center, representing a star or a planet, it creates a dip. That dip is gravity. But here's where it gets crazy. Gravity doesn't just pull on matter, it pulls on time itself. The deeper you are in a gravity well, the slower time ticks for you, compared to someone on the outside. This is called gravitational time dilation. Did you know that the GPS satellites orbiting Earth have to account for this? Because they are further away from Earth's mass, their clocks tick roughly 45 microseconds faster per day than ours. If engineers didn't use Einstein's equations to fix this, your phone's navigation would be off by kilometers within a single day. You are already living in a world of desynced time. But what if we took this to the extreme? If you stood near the event horizon of a supermassive black hole, the gravity is so intense that time practically grinds to a halt. To you, your heart beats normally, you breathe normally. But if you looked through a telescope at the rest of the universe, you would see stars explode and galaxies collide in seconds. You would be watching the history of the cosmos in fast forward. When you eventually flew away, you would have traveled thousands of years into the future. Science explained simply, this is forward time travel, and it is 100% mathematically and physically proven. We are already doing it. Cosmonaut Sergei Krikalev holds the record because of the high speeds he traveled at on the Mir space station. He has technically returned to Earth 0.02 seconds in his own future. He is, quite literally, a time traveler. But why can't we just turn the car around and go back? This brings us to the most stubborn law in the mystery of the universe, the second law of thermodynamics. This law introduces entropy, or the tendency of things to move from order to chaos. If you break an egg, you can never unbreak it. The energy spreads out and the arrow of time points firmly toward the future. However, deep science suggests that the arrow of time might just be a local perspective. If we could find a way to manipulate the density of space-time itself, could we bypass entropy? Physicists call these theoretical shortcuts Einstein-Rosen Bridges, or wormholes. Imagine the trampoline again. If you could fold the fabric of space-time so that two distant points touched, you could punch a hole through the middle. If one end of that hole is moving at near light speed, it creates a closed time-like curve. You could walk in one end and come out the other before you even left. However, the universe seems to have a protection agency against this. Stephen Hawking proposed the chronology protection conjecture, suggesting that the laws of physics will always conspire to destroy a wormhole the moment it forms, preventing paradoxes from shattering reality. Imagine a feedback loop on a guitar amplifier. As soon as the past and future connect, energy builds up until the system explodes. Because if you could go back and prevent your grandparents from meeting, you would never be born to go back in the first place. But what if the universe doesn't care about your grandparents? Quantum mechanics offers a wilder alternative, the many worlds interpretation. In this view, if you go back and change the past, you aren't changing your past. You are branching off into a parallel universe. You've created a new now where you exist, while the original timeline continues as if you never left. This leads us to the most controversial engine of time, light. Special relativity tells us that as you move faster through space, you move slower through time. If you could somehow exceed the speed of light, a feat currently considered impossible for anything with mass. The math suggests you would begin to move backward in time. But even without breaking light speed, we can exploit relativistic heavy ions. In particle accelerators, we see subatomic particles called muons that should decay in microseconds. Yet, because they are moving so close to the speed of light, their internal clocks slow down, and they live much longer than they should. They are, in a very real sense, small-scale time travelers. This brings us to the big discovery, and it's a revelation that changes the way we see our own lives. Most of us believe in presentism, the idea that only now is real. But many physicists today subscribe to the eternalism, or the block universe theory. In the block universe, the past isn't gone, and the future isn't unwritten. Instead, the universe is a giant, four-dimensional block of ice. Every moment that has ever happened, and every moment that will ever happen, is already frozen inside that block. Your birth, your first kiss, and the moment you die are all equally real and existing at specific coordinates in space-time. As the physicist Albert Einstein famously wrote upon the death of a friend, "Now he has departed from this strange world a little ahead of me." That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. If the block universe is true, then time travel isn't about changing the past. It's about visiting a different part of the block. You are not a traveler, you are an observer of a pre-recorded reality. This is known as the Novikov self-consistency principle. If you traveled back to the 1920s, you would find that you were always a part of the 1920s. Any action you took was already factored into the timeline. You didn't change history, you fulfilled it. This is the ultimate predestination paradox. It suggests that the universe is a closed loop, a masterpiece already painted, and we are just the brushstrokes moving through it. Deep Science Explained asks us if we are just following the grooves of a record that's already been played. Where does the observer come from? Let's look at the Tipler cylinder, a theoretical time machine that doesn't require a wormhole. If you could take a cylinder of matter 10 times the mass of the sun and spin it billions of times per second, the sheer centrifugal force would warp space-time into a spiral. If you flew a ship in a specific path around this spinning mass, you could literally spiral into the past. It's a terrifying thought that a sufficiently advanced civilization could treat the timeline like a deck of cards, reshuffling the order of events at will. But even then, the energy requirements are gargantuan. We are talking about the power of entire galaxies harvested to move a single human being across a single hour. But maybe we've been looking for the wrong kind of machine. Perhaps the time machine is already inside us. Our brains are prediction engines, constantly simulating the future and reconstructing the past. In the realm of quantum mechanics, some researchers suggest that entanglement might be a form of time travel. If two particles are entangled, a change in one affects the other instantly, regardless of distance. Some theories suggest this connection transcends time as well, that a particle today can be entangled with a particle from yesterday. If consciousness is a quantum process, are we traveling through time every time we remember or dream? So, how does time travel technically exist? It exists in the stretch of a gravity well, in the speed of a satellite, and perhaps in the very structure of reality itself. We don't need a machine to travel through time. We are already passengers on a four-dimensional journey that we are only beginning to understand. We are the architects of a reality that is far more flexible than our senses lead us to believe. Every moment you spend moving, you are shifting your clock. Every time you look at the stars, you are seeing the past. You are already a time traveler, peering through the window of a light year at a world that ended millions of years ago. But here is the final, reflective twist. If the future is already written in the block universe, do we have free will, or are we just actors following a script that was finished at the moment of the Big Bang? What if reality itself isn't what we think? What if time isn't something that happens to us, but something we are part of? A vast, shimmering tapestry where every moment is eternal. Maybe the reason we can't go back and change things is because the universe is too beautiful to be edited. Perhaps we are exactly where we are supposed to be, at every point on the line, forever. I'm your host, and this has been Deep Science Explained. If this journey through the fourth dimension made you look at your watch a little differently, hit the like button and subscribe. The future is already here. We're just waiting for the light to reach us. In our next episode, we'll uncover something even stranger. The negative mass theory. The exotic matter that could finally keep a wormhole open long enough for us to step through.